good evening. Welcome to day 3 of topic 1, enumeration. We're going to be talking about exponents and place value. So like I said yesterday, you guys are going to be getting a problem of the day at the beginning of your video now. So that problem of the day, you don't have to do it, but if you want to do it, I will give you $25 in your if you get it right. So here's your problem of the day. We're going to hold it up right here. And I'll read it for you. It says, a grocery store is selling 3 cans of green beans for 99 cents. How much do 4 cans of green beans cost? Alright, so go ahead and pause it here if you want to go ahead and work on that. You can just put that in the top of your PBIL section, show me how it work. And I'll go ahead and pause. If you're working on that, if not, go ahead and keep watching and we'll get rolling. Alright, so if you did your problem of the day, welcome back. If you didn't, welcome still here. Today, here's what our objective is going to be looking like. We're going to write powers and products and evaluate, write expressions in exponential form, and write numbers in expanded form using exponents. So it sounds like we're getting a lot done. There's going to be some vocabulary thrown today, so get your vocab sections ready. But we are going to roll with it. Okay, so you know the patterns appear when you repeatedly multiply numbers such as 5 or 10. So if we're counting by 5, we go 5, 10, 15, 20, 25, 30. Count by 10, it's 10, 20, 30, 40, 50, 60, right? So you know these patterns exist. Today you're going to learn how to efficiently represent repeated multiplication by the same number. So 5 and 10, you know, it's really easy, but we're going to be getting into exponents. So if you're ever given a number with an exponent, what does the exponent represent? That's kind of a question that I'm asking you to think about right now. It might be hard if you can't really remember what the exponent is. But what an exponent is representing is how many times the number is used as a factor. Okay, so that's a question I asked in class tomorrow. So be ready. I want to see all your hands go up. Know what that is. I'm going to ask you what does exponent represent. And remember, it's just how many times the number is used as a factor. Okay, if you can't remember what a factor is, what an exponent is, it's going to kind of throw you off. So we'll get into that and I'll explain what that means today. Okay, so to start today, what we're going to talk about is 10 times 10. That's the biggest of our lesson, 10 times 10. So what is 10 times 10? Hopefully right now you just have, it's 100, that's easy. Lesson done, cake, see you tomorrow. Okay, I wrote that on the board for you. 10 times 10 is 100. We're going to get a little more deep than that today. So I'm going to ask you another question. I'm going to say, how can you write 10,000 as a product of tens? Okay, if you can't remember what a product is, or that sounds kind of confusing, a product is the answer to a multiplication problem. So right now, we wrote 100 as a product of tens. So 10 times 10, we're just using tens, the product of these tens. When we multiply 10 times 10, we get 100. Now I'm asking, how can we get 10,000 as a product of tens? So I only want to use tens, but we know that only 10 times 10 is going to give us 100. So let's go ahead and do 10 times 10 times 10. Okay, go ahead and make sure you're following along in your PBIL. Follow, copy around the same notes that I do. 10 times 10 times 10 is going to be 1,000. So let's take it to the next level. 10 times 10 times 10 times 10. Again, we're only using 10, so it's a product of tens. And 10 times 10 times 10 is 10,000. So what I want you to do is just kind of stop for a second and think and see if you can see a pattern in these numbers that we just did. Okay, so let's take a step back for a second and think about what you already know. I'm going to throw up this place value chart here. And what I want you to look at is the ones column. Okay, and if you look, you can see that the periods are all labeled. We talked about periods the other day being 3 digits grouped together. So we've got the ones, thousands, millions, billions, and trillions periods. I want you to look at the ones period and look specifically at the ones column. Okay, we know that to get to the next period, we're going to have to multiply, or not to the next period, but to the next place value, we're going to have to multiply times 10. So you know that on a place value chart, each place has a value that is 10 times as great to the place to its right. So we know that the tens place is 10 times the ones place, or 10 times 1. The hundreds place is 10 times 10. The thousands place is 10 times 100. So what I'm going to do is I'm going to write a quick little pattern on the board. So if we look at our place values, we have ones, tens, hundreds, thousands, ten thousands, hundred thousand, and then we'll end with billions. Okay, so let's fix this a little bit for you there. All right, we know that to get from the ones to the tens, it's going to be 1 times 10. So now in the tens, this is 1, 10, 100, 1,000, 10,000, 100,000, and million place, right? All right, so to get from 1 to 10, we multiply times 10. 1 times 10 is 10. Now to get from tens to 100, we multiply, and it's going to be 10 times 10. We already talked about that earlier in the video. You knew that 10 times 10 was 100. So we could get from the tens to the hundreds, we just multiply times 10. Now to get from the hundreds to the thousands, we're going to multiply 100 times 10. To get to the thousands to the 10,000s, it's 1,000 times 10. To get from the 10,000s to 100,000s, it's 10,000 times 10. And that pattern is going to keep going and going and going. So if I wanted to get to millions from 100,000s, we're just going to do it times 10. So that fact that we can just multiply each step times 10 is pretty cool. That's why it's called a base 10 system. It's based on the number 10. Okay, so I'm going to write a number on the board. I'm going to write 100,000. All right? And here's what I want you to do. I want you to write 100,000 as repeated multiplication of 10. So again, all you're essentially doing is you're writing 100,000 as a product of tens. So what's that going to look like? Go ahead and do that now. All right, so hopefully this is what you wrote. 10 times 10 times 10 times 10 times 10 is going to equal that 100,000. Okay, so how many zeros are in 100,000? 1, 2, 3, 4, 5. So there's 5 zeros in 100,000. And what pattern do you notice for these multiples of 10? So we multiplied by 1, 2, 3, 4, 5. So what we did was, for however many zeros there were, that's how many times we multiplied 10. Okay, so now we're going to switch it up a little bit. I wrote a number on the board, so step aside so you can see it. Copy it down in your PBIO. And we read this as 10 to the 8th power. It means that 10 is used as a factor 8 times. And remember, when we did the products and we found 100 as a product of 10, each of those 10s were factors. It's the numbers that we're multiplying to get to the product. So it means that 10 is used as a factor 8 times. What number is equal to 10 to the 8th power, or 10 to the power of 8? Okay, so I just creep back in here. Hopefully you did that in your notes or you thought of it. I'm going to tell you it is 100 million. So 10 to the 8th power is called the exponential form of 100 million. In 10 to the 8th power, 8 is the exponent and 10 is the base. The exponent tells how many times the base is used as a factor. So what I want you to do is write 7 times 7 times 7 times 7 in exponential form. So go ahead and try that on your own right now and see what you get. I'll give you a couple seconds. Okay, that's a couple seconds. So what we should be looking at is 7. Oh, maybe not you're looking at it. Here it is. It's going to be 7 to the power of 4. So you can use exponents to write a number in expanded form. For example, 100,000 equals 1 times 10 to the power of what? Well, it's 1, 2, 3, 4, 5. 100,000 is 10 to the power of 5. So there's a 1 in front, so it's 1 times 10 to the power of 5. So now what I want you to do is write 80,000 in expanded form with exponents. So go ahead and see if you can do that on your own. And I'll give you just a second. And if you wrote 8 times 10 to the power of 4, you would be correct. So we have 8 is out in front. 8 times 10 to the power of 1, 2, 3, 4. 4 zeros, we're to the 4th power. Okay, so what I want you to do now is flip to your vocabulary section, and we're going to break down what some of the terms we just talked about. And if after we break down the terms, if you want to go back and watch the part that we just talked about using them, that might be beneficial so you can kind of get a better grasp on it. Okay, so now you should be in your vocabulary section. We're going to do a few vocab words very quickly. The first vocab word that I want you to write down for this section is going to be base. So base is going to be a number multiplied by itself the number of times shown by an exponent. So it is a number multiplied by itself the number of times shown by an exponent. Okay, so that's the definition for base. I'm going to step aside and let you copy that if you need to. Go ahead and pause it. And then we're going to move on to the next word. So go ahead and pause it here if you need to get caught up on that definition. Our next definition is going to be exponential form. So exponential form is a way of writing repeated multiplication of a number using exponents. So a way of writing repeated multiplication of a number using exponents. So again, I'm going to step aside and I'm going to give you a second to copy that down. An example of exponential form would be 10 to the power of 8. So it's a way of writing a repeated multiplication of a number. So this is going to end up being 10 times 8, 10 times 10 times 10 times 10 times 10, 8 times. But we're just using the exponent to show that, so we're not writing it all the way. So that's exponential form. So go ahead and pause here and catch up if you need to. last term is going to be exponent or power. Okay, so these can be switched out. They can be both used for the same thing. So what that's going to be is the number of times the base is repeatedly multiplied. The number of times the base is multiplied. Okay, again, you can pause it here if you need to. I'm going to give you an example as well. And we're going to label it a little bit. So right here, the 8 is the exponent, also known as the power. The 10 is the base. And overall, this whole thing is going to be called exponential form. Okay, so you can't see that. I'll move that a little bit for you. So go ahead and make sure you have all that in your vocab, and then switch back in your notes to your guided practice section, and we're going to get started on that.
Guided practice!
Okay, so as you saw there, we're now to our guided practice. Here's what we're going to do. I'm going to walk you through a couple examples at that beginning got you a little confused with exponents. So, number one, I want you to go ahead and write 10,000. And what we're going to do is we're going to write 10,000 as repeated multiplication. Okay? So repeated multiplication, we're writing 10,000 as a product of tens, right? So what I'm going to do is I'm going to look at my count. 1, 2, 3, there's 4 zeros. So writing that as repeated multiplication, you remember there's going to be 4 tens. 10 times 10 times 10 times 10 is going to end up being 10,000. So again, all we have to do there is we just have to count the zeros. It makes it nice and quick and painless. For number 2, what we're going to do is we're going to write 7 times 7 times 7 times 7. We're going to write 7 times 7 times 7 times 7 in exponential form. If you remember, exponential form is we're going to take the base number, and the exponent is going to be how many times we multiply the base number by. So right here we have the base number is 7 because that's the number that's repeating. And the exponent is how many times we used it. 1, 2, 3, 4. So 7 to the power of 4 is going to be the answer for number 2. Number 3, we have a problem, and it says to write 37,169 in expanded form using exponents. Okay. So, I'm going to get down low down here so we can get everything in. So, 37,169 using exponents. So, remember, I said that you can show expanded form 2 different ways. There's one way where you say the digit times the place value, or you just write it all out in one. For this, we're going to have to do the little more steps way. So, what we're going to have to end up doing is 3 times 10 to the power of what? Well, 3 is in the 10,000s place. And we know that to get 10,000s is 10 to the power of 4. So 3 times 10 to the power of 4 is going to be our first little section. Plus 7 times 10 to the power of what? 7 is in the thousands place. To get to thousands, we have to multiply 10 3 times, right? So 7 times 10 to the power of 3 plus 1 times 10 to the power of 2, because 2 times 10 is 100. We're in the hundreds place for that. Plus 6 times 10. And now for 6 times 10, we can go ahead and put to the power of 1, because it's not going to make a difference. It's going to be pretty much saying the same thing, and we'll move you over here a little bit more. 6 times 10 to the power of 1, we're just saying to the power of 1, there's only 1 10. So we're just going to go ahead and leave that just as we're doing that. And then 9 times 10 to the power of 0. We have to the power of 0 because there's no 10s. So since it's times just 9 by itself, there's no 10s there, so 9 to the power of 0 is how that's going to look. Okay? So go ahead and get caught up. Copy that down if you need to. And again, if it helps at all, what we can do is I will show you that 3 times 10,000 plus 7 times 1,000 plus 6, nope, plus 1 times 1,000 plus, we're going to go down to the second here, 6 times 100 plus 9. Okay, and I was looking back and I just caught a mistake that I made. Make sure that when I was showing you how this looks, it's 7 times 1,000 here. 1 times, it's not 1,000, it's just 100, and that threw that off there. But that's just showing you that this does translate into exponential form. It's looking for place values. Again, the simpler way would have just been 30,000 plus 7,000 plus 60 plus 9. All right, continuing in guided practice, we're going to look at number 4. Okay, for number 4, our problem is to write 5 to the 3rd power in standard form. Okay, the quickest way to get to standard form that we're going to do to show this is 5 to the 3rd power. What that means is that our base, 5, to the power of 3. It's 5 of them. Okay, now don't just look at this and say 5 times 3 is 15. That would throw you off a little bit. We have to look at this and say, what's 5 times 5? 5 times 5 is 25. Now, we're done with these numbers. What's 25 times 5? Well, 25 times 5 is 125. So, 5 to the power of 3, or 5 to the 3rd power, is 125 in standard form. Okay, let's look at number 5. For number 5, I'm going to ask you a question. I'm going to word it a little differently now, just to make sure that you understand. So if I ask the question, how many times would 10 be repeatedly multiplied to equal 100,000? So how many times would you have to multiply 10 repeatedly by itself to equal 100,000? Okay? I want you to just kind of stop and think about it. Jot down a number. And your answer should be 5. Okay? So when we talked about exponential form and exponents and all that, we looked at counting the zeros. And we had 5 zeros here. So 10 to the power of 5 means that we're doing 10 times 10 times 10 times 10 times 10. So we had to multiply 10 to the power of 5 times to get to 100,000, which has 5 zeros. So to answer our question of how many times would 10 be repeatedly multiplied to equal 100,000, it's going to be 5. And our last question is going to be number 7. Oh, I'm sorry, we skipped number 5. So this is actually, that was number 6, this is number 7. That was wrong. That was number 5. This is number 6. Go back to first grade for this. Here we go. Number 7. I just told you the number 6. Let's go to number 6 instead. Number 6. Raise your hand if you're confused. All right, I saw some hands. We'll get this figured out. Just keep adding some hands. All right. Number 7. How many zeros are in 10 to the power of 7 when it is written in standard form? Bonus question, what form is this? You're right, it's exponential form. Good job. All right, so when we're going to put this in standard form, it's going to be 10, and then we're going to add 7 zeros because it's 10 to the power of 0, because it's 10 times 10 6 times 10. Hopefully we didn't get off the board there and you can see it all. So 10 to the power 7, all these 10s when multiplied are going to be we're going to have 7 zeros. So it's going to be 10 million. There will be 7 zeros. You didn't even have to work that out if you understood the question. So that's it for your guided practice. Now what I would like you to do is go ahead and get on to SuccessNet and go ahead and take your quiz. Remember, record your quiz score in the quiz section. Give me all of your notes from your quiz. And go ahead and email me your quiz score, please. And that way we can get class started, ready to go tomorrow. If you have any questions, remember you can always see me in class tomorrow. So if you're just completely, utterly confused, excellence can be kind of tricky if you haven't done it before. Don't freak out, don't worry about it. Do your guided practice. Watch it a few more times if you need to. Watch it one more time. But you can always talk to me in class tomorrow and we'll get it all figured out. So, thanks for watching lesson 3 in topic 1, and I will see you tomorrow in class.